Boolean logic is concerned with what is true and what is false. In Haskell, we have the bool type, which has only two valid values, true and false. There are a number of functions we can use to perform Boolean logic. The first type of Boolean function is testing for equality. There are two functions here. The first is two equal signs, which tests that whatever is to the left of it is equal to whatever is to the right of it. So if the two arguments are the same, it will return true, and if they are not, it will return false. The second is a / followed by the equal sign. This tests that the two arguments passed to it are not the same. So if the arguments are not the same, in other words, they are not equal to each other, it will return true, and if they are equal to each other, it will return false. The reason for using this syntax is that it kind of resembles the not equal to symbol used in mathematics, which is an equal sign with a slash through it. Obviously, the mathematical symbol is not readily available on keyboards, so it is much easier to define not equal like this. Let's take a look at some example code here. All of the variables C, D, E and F are of type bool. This means their underlying value will always be either true or false. For C, we are testing whether 2 is equal to 2. Obviously this is true, so the value of C will be the bool true. For D, we are testing that 3 is not equal to 3. 3 is obviously equal to 3, so the return result will be false. For E, we are testing that 2 is not equal to 3. This is obviously true. And lastly, for F, we are testing that 125 times 0 is equal to 0, which is true. The next type of Boolean function is for comparisons. The two values which are being compared must be orderable. So for G, we are testing whether 512 is less than 1024, which is true. For H, we are testing whether 1024 is less than or equal to 2, which is false. For I, we are testing that 256 is greater than 32.25, which is true. And for J, we are testing whether the string A is greater than or equal to B. Now in the alphabet, A comes before B, so A is considered to be less than B in terms of ordering. So testing whether A is greater than or equal to B results in false. These examples are shown using the comparison Boolean function on ints, doubles and strings. It is possible to do that because they all follow a well-known ordering. The next type of Boolean function is for combining Booleans. There are two functions for combining, logical AND and logical OR. The function for logical AND is two ampersands placed together, and the function for logical OR is two pipes placed together. Before we look at code, let's look at a truth table to better understand it. Suppose we have two variables x and y, which take the value either t or f, where they represent true or false respectively. So if x is true and y is true, then x and y will be true since they are both true. X or y will also be true since at least one of x or y is true. If x is true and y is false, x and y will be false because at least one of x or y is not true. X or y will be true, and so on for the rest of the combinations. Now let's look at some code using the combining functions. Here, k and l are bools. K combines two Boolean expressions using the double ampersand, which, like we said before, stands for logical AND. The first condition of 512 being less than 1024 is true, but the second condition of the character C being equal to the character D is not true, and so K is false. However, L has the same two conditions but is performing a logical OR. Since the first condition is true, the logical OR is true. The last type of Boolean function I want to cover is negation. This one is simple. Put in front of a Boolean, this will just turn it into the opposite. So if placed in front of true, it will turn it to false, and if placed in front of false, it will turn it into true. Now here is some code to test your understanding. This code is intentionally harder than the others. Let's go through it together. M is equal to not whatever is in the brackets. So we evaluate the brackets first. We have true, which by definition is true, and J, which is false. So true and J is false, and we are negating that by using the not function, so our result is true. N is equal to not false, which is true, and true. Since we are ANDing true with true, the result is true. O is equal to false, or not H, or not I. So we know H is false, and so not of H will negate false to true, and true back to false. And we know I is true, and if we not that, we get false. So this expression is false, or false, or false. And so the result will be that O is equal to false. That's it for Boolean logic. It can seem like quite a lot if you are new to it, but after a while of using it, you will get the hang of things. This video is a clip from a longer video for beginners starting with Haskell. Check that out if you would like to see all of the content. Also check out the entire Introduction to Functional Programming with Haskell course on the Learn channel. See you next time.